So we're back for step 5-2, where the goal is to structure a bit what we've just done. If I go back to it, we've ended up with something like this. Our BalanceCard app has 4 different variables that are inputs. Very good. That means our app component can send it data. Great. Here, what we're going to use, especially to use TypeScript's type system, so it's really a typed version of JavaScript. We like to have types for pretty much everything. It helps us structure things a bit and gives developers some constraints on how to use certain data sources. Because here, as we can see with BalanceCard, we're going to have a data structure that's specific. A BalanceCard has a label, an amount, a converted amount, and a currency. We're going to encapsulate all of that in what we call an interface. In the Java world and in other languages, it's more like what we call a class. In TypeScript, though, there's a pretty significant difference between a class and an interface. We'll see that a bit later. In any case, for this data representation intended for the front end, it's a kind of contract that says this business object must be written with these different attributes. In TypeScript, especially with Angular, we'll use an interface. To show you a bit, it would look like this. If, for example, I create an animal file, let's say, I would have a name of type string. What else could we have? Sound, a string, etc. That's how it would work. Here, we are saying that our animal interface must necessarily have these 2 things. This then allows us to, for example, create an application that will be of type animal. Here in particular, my IDE tells me there's a problem, that these 2 names are missing. So we use this, and we can, for example, do implement all members. Here I'm going to have a cat that I call cat, which goes meow. Anyway, that's the idea. That was just to clearly show a little bit how interfaces are effectively used. In step 5, this object that will be more or less the goal of step 5.2. In step 5, we set up the inputs. Now, we're going to try to structure this data so that all this information is concentrated within a TypeScript interface and used in the same way. So the goal is to move everything we have in BalanceCard into a TypeScript interface, update what we have in BalanceCard so that it now uses a single variable of the TypeScript interface type that we're going to create, and update the corresponding HTML. I'll let you do it. So we are meeting again for the end of step 5-2. Let's take a look at what we've managed to do here. So the change here wasn't the most difficult one. However, you really need to keep this concept in mind. It's heavily used in Angular that here. We're going to type with angle brackets. It's also something you can do in Java. We type the variables that will pass through this balance variable, which will be of type CurrencyBalance. CurrencyBalance, which is my interface, will have this structure. This is very similar to what I showed with the animal interface I created just before, but here we just update it with the variable we need for this CurrencyBalance representation. So it's used in this way. The impact on the HTML is quite simple because now we have this object, this TypeScript interface. We use the functions on this input, and then we can go and read inside all the attributes we've set. So as soon as we call BalanceCard is of type CurrencyBalance, whenever we call the function to read the data from the input, we have access to all these variables. Here, we update the label, which was a specific input with balance. Then we retrieve the variable inside. And it's the same for all variables we had before. Now, we only refer to this single balance input. Regarding the impact on the parent component, there were 2 ways to do it. One way is to use signal directly on it. We haven't necessarily seen it, but one of the possible ways, which also worked, was to have something like this. Okay, so I simply create an object, and instead of sending it using the inputs read function, we can use this object directly. Then, since app BalanceCard expects to receive a variable of type BalanceCard, it can remap it and provide inside BalanceCard a variable of type signal. Well, a variable of type BalanceCard, but in the form of a signal and therefore as an input. So we're good, but in the long run, we'll prefer to consistently use this kind of notation. Using the signal, which will allow users, we'll see later in the chapter about Angular signals, it will then let us benefit from all the features that come from using signals. We can review a bit what we said in step 5, but here it is one of the extremely important principles to really understand, because it will truly help us structure our applications much better in the long run, is this system of DOM and smart components. Now, our balance card is a DOM component. The app component has always been a smart component, but now its role will be to fetch the data, whether from a service, a store, etc. And to send that data formatted in the right way to its own DOM components. Also, we've finally started to type our application. We're really starting to use TypeScript typing by using interfaces, and this will really be used a lot. One convention could be to put all our interfaces in a model folder, though that's not strictly necessary. That will depend a bit on the architecture of each project, but it's one of the possibilities. So that wraps up step 5.2, and we can move on to step 6.